Hello, and welcome back to What Is, the channel dedicated to demystifying the technology that runs the world. Today, we're tackling a concept that still feels like it was stolen from a science fiction movie. The 3D printer. It's a device that can conjure physical objects out of thin air. Or at least, out of very thin layers of plastic dust, metal powder, or sometimes even bio-ink. But what is a 3D printer, really? Is it a modern-day replica of the Star Trek replicator? And how did we get from giant, industrial laser machines in the 1980s to affordable desktop models sitting in garages today? Let's find out. At its most basic, a 3D printer is a manufacturing machine. But it operates using a radically different principle than traditional methods. Think about classic sculpting or woodworking. That's called subtractive manufacturing. You start with a big block of material, a hunk of marble or wood, and you cut away everything that isn't the finished product. It's wasteful by design. A 3D printer, however, uses additive manufacturing. It builds the object layer by microscopic layer, adding material only where it needs to be. You load up a digital blueprint. The machine gets to work, and the final product emerges from the void, whole and complete. If a traditional sculptor is chipping away at a rock, the 3D printer is essentially an extremely precise, digitally controlled hot glue gun, drawing and stacking hundreds of thousands of two-dimensional images until they stack up into 3 dimensions. The birth of 3D printing, or as it was initially known, rapid prototyping, happened in the 1980s. But it wasn't a sudden invention. It was the culmination of clever work by several people trying to solve the problem of making prototypes faster. The primary credit usually goes to American engineer Chuck Hull, who was working at a company called 3D Systems in 1984. Hull wasn't building toys. He was trying to find a faster way to cure thin coatings of plastic resin using UV light. He realized he could use this process to build an object layer by layer. Hull patented the first technology we recognize as 3D printing, stereolithography or SLA. Stereolithography involves a vat of liquid polymer resin. A UV laser traces the cross-section of the object onto the surface, hardening the liquid into the required shape. The platform then dips down slightly. The laser traces the next layer, and so on. By 1988, 3D Systems released the SLA 250. It was groundbreaking, but utterly proprietary, gigantic, and cost hundreds of thousands of dollars. This wasn't a consumer product. It was a high-end industrial tool designed for aerospace companies and major manufacturers. For the next 2 decades, 3D printing remained locked behind high prices and corporate walls. But change was brewing, thanks to a simpler technology patented slightly later: fused deposition modeling. FDM is the technology most commonly associated with desktop printers today. Instead of messy liquid resin, FDM uses a thermoplastic filament. Basically, a massive spool of specialized plastic thread, which is melted and extruded through a tiny nozzle. The real revolution arrived around 2005 with the launch of the RePrap project. RePrap was founded by Dr. Adrian Bowyer at the University of Bath. The goal was radical: create a self-replicating, open-source 3D printer. By making the technology open source, meaning anyone could access, use, and modify the blueprints, they effectively set off a bomb under the industry's proprietary wall. Suddenly, costs plummeted. Small businesses, hobbyists, and schools could afford to own a machine. FDM became the home version of 3D printing. This shift gave rise to a funny phenomenon: the democratization of manufacturing. Before, only a major factory could create a specific plastic widget. Now, A 12-year-old in their bedroom could print a tiny replacement doorknob, or maybe a slightly ugly 3D printed whistle, in the span of an afternoon. Today, 3D printing refers to a huge family of technologies. While FDM printers sit on desks printing plastic figurines, the industrial end of additive manufacturing is transforming every major industry. We can now print with almost anything. Selective laser sintering, or SLS, uses powerful lasers to fuse metallic or ceramic powders together. This allows engineers to create complex, lightweight parts for rockets and jets that couldn't be manufactured any other way. In medicine, bioprinting uses biological materials to create scaffolds for tissue engineering. We're not quite printing human organs yet, but printing medical models, custom prosthetics, and personalized drugs is already standard practice. And the process speeds up every year. From the first slow, clunky SLA machines of the 80s to modern printers that can build a house in 24 hours, 3D printing is no longer just for prototypes. It is a genuine, efficient, and increasingly sustainable form of final product manufacturing. So, what is a 3D printer? It is the closest thing we have to a machine that can bring a digital idea directly into the physical world, laying the foundation for a future where anything that can be designed can, literally, be built. If you found this deep dive into additive manufacturing useful, make sure to show us some love. Hit that like button. Subscribe to What Is for more comprehensive breakdowns of complex technologies, and let us know in the comments below. If you had a 3D printer, what's the first thing you'd build? Thanks for watching, and we'll see you in the next one.